This is class 2 of our deep learning playlist. If you remember, last time we took baby steps. This time we'll do more on that, and you will get a practical viewpoint of how neural networks work. Let's directly get into it. If you remember in the last class, we took only 2 neurons. Now we want more. Suppose I will take 5 neurons. 1, 2, 3, 4, 5. I've taken 5 neurons, okay? And I want to connect here this way. And the connection will be like this, as I already mentioned you. This will be a fully connected neural network. When I say fully connected neural network, each neuron from the first layer, that is the input layer, will be connected to all the neurons in the second layer, subsequent layers. Here, the second layer. Now, when all are connected here, we have to take more weights, and also we have a bias. Which side you write, it's your choice. Suppose, let me write this way. This is only a diagrammatic representation. Will not worry much about this. Okay, so let me write now. Suppose this is my first input x1, this is my second input x2, this is my third input x3, this is my fourth input x4, and this is my fifth input x5. So I have 5 features here. I have 5 features and one target. On the basis of x1, x2, x3, x4, x5, I want to get the value of y. Okay. My application, whatever I will do, I'll make a web application or a mobile application. In that application, someone will put these 5 values and he has to get y. Okay. How this will be done? Let me write the mathematical formula. Before that, let me write what is x1 here. Okay. So let me erase. I don't have space here. So I erased everything. Just remember, I have written 5 variables x1 to x5. So the first one I can write here. The first one is, suppose, age. And the second one is income. And the third one is gender. And the fourth one is genetics and income. These are the variables. On the basis of these variables, you are supposed to decide whether the patient will be admitted in the hospital or not. When I say patient here, an admission, hospital admission. So let me draw one here. Suppose this is the hospital, and we have the patient also. Okay. So suppose this is the hospital, and here this is a normal house. Okay. Now, if you see here, this guy will be admitted or not. Okay. Staying in this house. And now you need to decide whether you need to admit this guy in hospital or not. So if you want to take a decision, you have to base on certain things, right? So how many things we'll consider here? At least in this one, we are considering 5 factors. Okay. What are the 5 factors here? If you see, we have written these 5 factors one by one. If you see, the first one is age. Will age depend? Yes. If someone is 80, let me write the data. Let me write the data here. So I have to write 5 columns and plus 1, 6 columns here. So this is my data. So let me make 6 columns. One, the first one, that is age. Second one, income. Third one, gender, male or female. Fourth one, genetics. The fifth one is income. And the sixth one is whether this guy will be admitted in the hospital or not. But I will change a bit here. So I'm taking 3 or 4 rows of data according to the space availability. Now you see, I've taken how many rows? 4 rows of data. Okay. So let me write here. This is my x1. X1 is this, the first input. Okay. That is age here. This is my x2, the second input, that is income. And this is gender, the third one, that is male or female. Okay. Suppose you take male as 0 and female as 1. Okay. And this is x4 and this is x5, because everything will be transferred to, let me write, male I've taken 0 and female I've taken 1. We'll later learn how to transfer all the categories into numbers, okay? Because a neural network will take only numbers, right? X1, X2, age. Age, suppose 70 years I will take here, 20 years I will take here, 1 year I will take 30 years, okay? These are the 4 ages. And the second one is income. Suppose this guy gets 80,000 a month. This guy gets, 1 year, better, no, I'll take 12 year, okay? So the income could be 1,000 a month, okay? Here 30, it could be 30,000 a month. Here 70, it could be 20,000 a month. Now, if you see X4 here, that is genetics. Again, genetics also you can number 0 to 10 according to the disease, okay? So suppose randomly I'm writing 0, 1, 2, 0. We have to divide into some categories, okay? Because genetics also plays a role. If you don't want, you can take any other thing here. Only for the illustration, I'm saying. Now, income. I've written income here, double, okay? So what we'll do is, we'll cut this income and we'll make another one, okay? So let me erase this, first of all. So if I want to erase this, I have to use this, done. Now, I have to write another one, okay? I have to write another one. So I've already taken age. Age will matter, distance will write. Let me write distance from the hospital. Now what will happen? Distance from this, this house, wherever this guy stays, okay? From this one, this guy, whether this guy will be admitted in this hospital or not, that is the question. So the distance matters here, okay? So according to the distance, the decision will be taken. Suppose the distance is very high, 70 kilometers, okay? Suppose the distance is 70 kilometers here. Suppose the distance is 2 kilometer. Suppose the distance is 5 kilometer. Suppose the distance is 10 kilometer. Then you need to decide whether to admit in the hospital or not. Why for admitting in the hospital and for not admitting in the hospital? So this is a classification task. We have to classify, okay? But I'm not doing classification tasks in this class, okay? Because I started with regression. For classification, I need to change the neural network, okay? So what I will do is, I will change it to a regression task, okay? But remember, this kind of a typical example you will see for a classification task. But we can change it to a regression task. If you don't know regression and classification, you can go through my machine learning playlist, okay? Regression is what? That will give you a particular value, will base on some variables, and whatever score you will get, that is regression. Normally, it's a continuous variable. And classification, when you say, you have to classify male, female, yes, no. Somebody will fraud. I'm talking about the credit cards, fraud or not. Those things you have to decide. Now, let me erase this. We'll change it to a regression. The same example I will do in the next class for a classification task. I will introduce once again classification and we'll do accordingly. Okay, no worries. Now, what I will do is, I will change it. Y will be the total hospital expenditure. Instead of whether this guy will be admitted in the hospital or not, that we'll do in the next class. Okay, that will be a part of classification. And typically, you will see this kind of an example. Now, in this example, because this neural network is for a regression task, we'll say whether this guy, no, for this guy, how much will be the final cost. So, the total expenditure. If you admit in the hospital, the question is, what is why? Why is, if you admit in the hospital, what will be the cost? Okay, so you can say the expenditure, the expense. Okay, you have to estimate the expense. You have to estimate the expenditure. So how much you have to spend here? Suppose you need to spend 50K here. In this case, okay, this is an old man, and for this guy, suppose 40K. 12-year, again around 50 or 60K. 30-year, again suppose 20K. This is the expenditure. So we are predicting here, if you admit in the hospital, what will be your expenditure? Okay, that is what we need to predict here. So what will happen? Let me erase this. I have to find the value of Y. I have to find the value of Y. What will happen? I will write a formula which will capture all the variables x1 to x5 called features. Now, my formula is this. y is equal to, let me write here, my formula is y is equal to, let me erase all. Suppose this is B1, this is one weight, this is the first weight. We start with this, right? A is the bias, and then I will write B1 x1, B2 x2, B3 x3, B4 x4, B5 x5. This is my equation. What will happen? When you train with these 4 rows of data, that means someone who is aged X, I mean, X1, 70 age. Suppose you take first row data, age 70, income 20K per month, X3 is gender, male I've taken 0, and X4 is my genetics, okay, some rating, 0, 1, 2, whatever. X5 is the distance from the hospital. And finally, if you admit in the hospital, because distance also matters, right? Sometimes you have to pay taxi, and if you might need to book also a taxi, okay, if you are from a village area or small town. So all those things will come here. So distance from the hospital also matters whether to admit or not. Suppose someone is staying 100 kilometers away, someone is staying 1 kilometer away. They're different, right? That's why. But anyway, now this is a regression task. We are predicting the final expenditure. If you admit, what will be the expenditure? That is what we want to predict here. So you will get the answer y, that is called target. So y is equal to a plus b1 x1 plus b2 x2 plus b3 x3 plus b4 x4 plus b5 x5. This is the equation, simple equation. Done. I'm repeating now because this is your initial days. This is only second class, right? In the later classes, I will be very fast, okay? Let me know in comment, okay? If you want me to teach faster, I will do that. But I'm not going faster because this development is very, very important. There won't be any doubt in future. Keeping that in mind, I'm repeating, okay? Anyway, so input anyway, one will give, suppose we train the neural network. So once neural network is trained, your weights are fixed. Now your weights are fixed, okay? Because you train the neural network. How you train the neural network? Using 4 rows of data. So then the question will come, you will train the neural network with all 4 rows at a time, or 1 row at a time, or 2 rows at a time. Again, that will come later in the subsequent classes. We'll go to the coding area, okay? So there is a concept of gradient descent, stochastic gradient descent, mini batch gradient descent, but I'm not going to that. Remember, ultimately, if you train using these 4 rows, if you train using these 4 rows, this data, that means this data will try to find a link between 50 and these 5, okay? Suppose 70 multiplied, it will be like this, 70 multiplied by some number, 20 multiplied by some number, 0 multiplied by some number. Here I've written 0. 0 multiplied by some number, 10 multiplied by some number. That should be equal to 50. Plus the first one is also there. Okay. Why? Let me write 50 here. 50 is equal to, here I have to write, okay, let me erase this. I'm not using this cell, right? So we'll write here only. So what will happen? Now, 0 multiplied by this one, 0, right? 0 multiplied by something, we don't know, plus 10 multiplied by something. So what will happen? This is my 50 is my, and this one also I need to erase. Now see. Let me write properly. So what is training the neural network? Okay. So what is training here? What neural network will learn here? That's what we want to know. So if you see the first row, 70, it will check what is that A when you add, and what is that B1 when you multiply with X1, what is that B2 when you multiply with X2, that is 20, what is that B3 you will multiply with X3, that is 0, what is that B4 you multiply with X4, what is that B5 you multiply with X5, so that you will get 70. Okay. So you see here, this one, let me take this. So this one, not for 1 row, for all 4 rows. Remember, you can't change different, you can change for different rows, different AB1. They should be same. You have to find ultimately manually or whatever way possible these values in such a way that in such a way that all 4 rows are satisfied mathematically. Okay, that is the intuition. So what will happen mathematically if you find the values of A1, A, B1, B2, B3, B4, B5? Not only for 70, for 20 also. For 20 also similar equations. Okay, A, whatever is A, plus then this is 20, right? 20 then 80. You write multiplied by 80. You continue that way. So you write these 4 rows here. This is the first row, second row, third row, fourth row. So you have to find those values of A, B1, B2, B3, B4, B5 for which the loss is minimum. Because what I'm saying is, you can find exactly A, B1, B2, B3, B4, B5, which will satisfy all equations. You can find, you can never find. Okay. Because the data is not according to our wish. That is real world data, practical data, whatever way the data is, that way it will be. So according to our wish, will not get. So ultimately, what will happen? You have to compromise. Okay. Now, how you compromise? See, I have how many weights and biases ultimately, and those I need to estimate. I have these weights and biases. Okay. I have A, I need to estimate, B1 I need to estimate, B2 I need to estimate, B3 I need to estimate, B4 I need to estimate, B5 I need to estimate. So suppose these are the two guys, they came up with different, suppose this is 2, this is 5.5, this is 0.1, this is zero point 0.2, this is 0.15, this is 0.10, whatever. And this guy, this is A, and this guy is B. This guy comes up with the weights 1, 0.1, 0.1, 0.7, 0.9, 0.12. Okay. So ultimately, I need these, right? So that whenever a customer gives X1, X2, X3, X4, X5, I'll be able to get Y. Because ultimately, Y is A plus B1, X1, B2, X2, B3, X3, B4, X4, B5, X5. So these are the weights and biases. Only one bias here. 5 weights. These are the weights and biases the neural network has to learn from the 4 rows of data. So suppose I've given this task and they've done differently. Okay. Someone has done manually, someone has used some kind of algorithm, or they use different algorithms. How I need to decide? So what I will do is, I will see the loss, ultimate loss. Loss means what? That also will study. Okay. As I already mentioned you, we are doing in installments. All right. So suppose loss is 2 here, loss is 3 here. So I will accept these and I finalize. Okay. These I will finalize. Once I finalize my weights and biases, then I can inform that my neural network is trained and I have a trained neural network. Now, whoever comes, it will be able to predict whether they have money or not, how much money they need if they want to admit the patient in the hospital. Then, okay, let me erase now. So if you have any question, don't mind, please ask, because these initial classes are very, very important. Once you develop the basics, then the life will be smoother. We have a long way to go, right? 200 classes, 200 classes, okay? But yes, if you're able to understand the level, whatever level, whatever way we are doing, it will be that way only. It will not be drastically more difficult. Okay. Now, let me check with this. So I have a neural network now, which is trained. I have a trained neural network. Okay. Because I have trained it using whatever data I had, 4 rows of data. Now, what I will do is, if I know, otherwise I have to learn, I'll make a web application. Okay. In this web application, what will happen? I will keep this is a front end. I mean, this is the interface, you can say. Okay. So here I will write boxes 1, 2, 3, 4. Behind my neural network should work. Okay. Behind this neural network will work. What will happen? There is a neural network. Okay. This trained neural network. Okay. I have to, I mean, what I want to say is, suppose a new guy comes. Okay. Whenever you give a request, you will get a response. Okay. So that is backend. This front end interface only you have to put. So for a customer, okay, it doesn't matter who is training, what is training, what is a neural network. Okay. Customer comes here. Okay. Or suppose I will make a link of this. I will, this is my, my simple web application. So what I will do is, I will deploy it. Okay. Once I deploy it, then I will make a small one page, this kind of a web application. And what will happen is, here, this one, there will be a link, right? So that link I will send to my friend, or whomever wants this. Okay. So what I'll do is, I will send this one. Suppose this is the link, whatever link HTTP or HTTPS. Okay, this is my link. With this link, this guy will be able to access to this browser. Okay, now what will happen through browser? This guy will get this page. So here he has to write all these five: age, then income he has to write, he has to write gender, he has to write genetics, he has to write distance. And suppose genetics, he will not be able to understand. You write all this, okay, according to whatever you have decided this way. So you can write here, okay, in the right hand side, you can make a column, and whatever you want to write, he will decide in which category he falls. According to that, he will write here, okay, no issues. Now, he will write all, okay, his age he will write. It could be 37, okay. First one is age, income could be 150K, doesn't matter, okay. Then the third one is gender, female. Like this, he will put all these values. And the fifth one is distance, suppose 5 kilometers. And what will happen? He has to click, you have to make a button here, okay. Even if you don't know, you ask your software friend. It's not a very difficult task, okay. You can do in one day. Then here, you will get the answer, boom. You got the answer now. Because once you give a request, okay, by uh, writing all this is input, you will get the output, okay. The response will come actually, that whatever request you will give, okay, this link is there. Through that link, so whatever link you have, there you will get the answer. That's all, okay. Now let's go further, okay. Now we'll talk. Now to this kind of a neural network, we'll give some more abstraction. How? We started with this neural network. In today's class, if you remember, 5 neurons. What I will do is, now I will have a hidden layer. Then I have output layer. Remember, we are talking about fully connected neural networks. When I say fully connected neural networks, all the neurons are connected to all other neurons in the next layer, in the subsequent layers, you can say, okay. This is connected to this is connected to this one is connected to this one is connected to this one is connected to this. Similarly, this one is connected to this one is connected to this. That way you can write. This is my fully connected neural network, okay. Remember, we are now doing fully connected neural network. Then what will happen? Once this is done, this is a feed forward neural network. You can say artificial neural network. MLP also, multi-layer perceptron. We'll go to that later, okay. But remember, this is a fully connected dense neural network. Again, dense you will hear. So these are the words you will see in different places. So this neural network has how many weights and biases? That we need to know, okay. So now this neural network has how many weights and biases? So this neural network, if I write, this neural network has, so here there will be one bias, okay. Here there is one bias, here there is one bias, here there is one bias, here there is one bias. So now the input are same: x1, x2, x3, x4, x5. I'm not writing the equations y1, y2, y3. There is a z or z here, whatever you say, okay. I'm not writing those. Ultimately, you can write mathematically, not required. Because you have to develop practically whatever minimum required, I'm saying. If you go deep into mathematics, there are a lot, and it's not required. So now, whatever final, I'm taking this as y only, okay. In between, you can write z1, z2, z3 if you want, no problem. Now, the biases are here 3 biases, here 1 bias. So I'm interested because the coding, whenever you write, TensorFlow will give you these values. So how many weights and biases values you have? Okay. Now from here to here, I have 5 multiplied by 3 plus 3 number of biases. Okay. These weights, 15 weights plus 3, 18. In total, 18 number of parameters you need to estimate. Okay. If you have a hidden layer. If you want to understand the intuition of hidden layer, I'll tell you that. No worries. Just remember. Now, why? Suppose I said here, if you remember, age, and then I wrote here the second one. I don't remember. Suppose it's income or gender, whatever. Gender, suppose I've written. Okay. So can you find one which is connected to these two? I mean, some way, age and gender connection. Or maybe there are 3 which are connected in some way. Sometimes when we write 2 or 3, they can be combined in one neuron. Okay. So there are so many examples. I'm not going to the complexity now. Just remember, These three are combined and the compressed information will be kept here in this neuron. So that slowly you will come here. Instead of directly coming here, you will come slowly. You are more deep actually. Okay. Now this is only second class. So I don't want to confuse you. So let me erase. Done. So now we'll go to this. Okay. Now let me write. Here 3 to 1. So 3 multiplied by 1 plus 1 bias. This bias. Okay. So 3 weights and 1 bias, that is 4. So total number of parameters to be estimated. Let me write. Total number of parameters. Total number of parameters to be estimated. So important. 22. Okay. All things I will show you in coding also in the next class. So 22 parameters you have to estimate. Even the neural network will take the data 4 row, 40 row, 4 lakhs row, 4 crores row. It doesn't matter. See the data when I say, it will not matter how many rows you have. Okay. We have taken 4 rows. You can take 40,000 rows. Doesn't matter. Because what will happen is for all 40,000 rows, see, first you have to send first row, suppose. You send the values here while training. Then second row, third row. That way, it doesn't matter. 4 lakhs, 4 crore rows you have, rows of data. All things you can send. Okay. Manually, I'm saying, but in coding, it's only 2-line code. Okay. So this is trained. Ultimately, you have to estimate 22 parameters. It doesn't matter. It will not depend on the number of rows. That's what I want to say. Now let me erase. So 22 number of parameters are there in my architecture, my fully connected neural network, my dense neural network, my you can say multi-layer perceptron, my artificial neural network, whatever. We have other variations also. Oh, sorry, I deleted that. That's required. So how many we have? We have 22 number of parameters, and these parameters I need to estimate. Okay. So it will learn, the neural network will learn the parameters finally, and once the parameters are fixed, the network is learned. Okay. It's a trained neural network now. The best values, when you say it's trained, the best values you have to find. Okay. Then you can save it and load it, all that. I mean, you can go to the next step or deployment. Okay. Deployment, and then you need to monitor also. That's a separate thing. Okay. That will come in the next stage when you do a project. But now remember, this way you can train a neural network. Okay. And these are very basics. You are supposed to understand these things properly. Then there won't be any problem in future. Okay. So this is a neural network where I introduce one hidden layer. So if I want, I can introduce more hidden layers as well. So this is a neural network where we have 3 layers: input layer, one hidden layer, and one output layer. And how many connections are there? We have 15 plus 3, 18 connections, and we have included 4 biases. So in total, we have 22 number of parameters. Those will be estimated during training. Okay. Your work is to train a neural network with some loss. If you feel that that loss is small enough, then you can fix this. Okay. Once you fix the parameters, you can say, I trained a neural network. Okay. That's what I wanted to explain in today's class. Okay. So class is over for today. And in the next class, you learn more. Okay. So please complete whatever I taught in today's class. And we'll do more in the next class.